Hello, Spartan fans. Section 7.3, we're going to do some more solving, probably a little bit more complex than what we covered in the previous video. Okay, so for all of these examples in this video, we are going to solve over the interval from 0 to 2 pi. So I get lazy and write it 0, dash 2 pi, but technically this is really what it looks like. So we're going to include 0, and we are not going to include 2 pi. Okay, let's look at the tangent of theta over 2 equals 3. The previous video, I used a substitution and I said, let x equal theta over 2, and then we solved using the tangent of x. I'm going to do the problems today using inverse notation instead. This is completely okay. You figure out where the tangent is root 3, and then you go back and substitute. I'm going to use inverse notation instead. So if I want to solve for theta, I'm going to say the inverse tangent of root 3 is equal to theta over 2. All right, so figure out what angle has a tangent of root 3. I believe that is pi over 3. Multiply both sides by 2, and you get theta is 2 pi over 3. Let's check to make sure there's only one answer. Omega in this particular problem is 1/2. The period of tangent is pi. So pi over omega is 2 pi. So the period of this particular problem is 2 pi. There is only going to be one answer. On the interval from 0 to 2 pi, we only hit a tangent of root 3 once. If I were to add like the next period, so where is it going to hit root 3 again? Well, 2 pi later on in the curve. Well, that's already going to be beyond 2 pi. If I add 2 pi to 2 pi over 3, I'm automatically greater than 2 pi. So this particular problem has only one answer. Okay, how about something like the sine of the quantity 3 theta plus pi over 18 equals 1. Okay, so previously, if I asked you to graph this, you would figure out there's no vertical shift, and you would say, okay, omega is 3. The period of this particular graph is 2 pi over 3. Omega is 3. Okay, then we would figure out the horizontal shift, the phase shift. Be careful. The phase shift is not left pi over 18. The phase shift is actually left pi over 54, I think. Let's just review that really quick. You would set 3 theta plus pi over 18 equals to 0. This is just a review. It's not necessarily pertinent information for this problem, but review is always good. 3 theta equals negative pi over 18. Divide both sides by 3, and you would say this is a shift left pi over, I believe 18 times 3 is 54. Okay, not necessary information for this problem, but like I said, review is good. What does matter for this problem is that the period is 2 pi over 3. Omega is 3, period of sine is 2 pi, divide, etc. So let's use the inverse notation to solve. To extract the theta from this argument, so to speak, I need to use inverse notation. So the inverse sine of 1 is equal to 3 theta plus pi over 18. Okay, where is the sine 1? Last I checked, that was pi over 2. Okay, so subtract pi over 18, divide by 3. I believe that's going to be 4 pi over 27. Subtract pi over 18, that's going to be 8 pi over 18, which is 4 pi over 9. Common denominator, et cetera, et cetera. So we get that theta is 4 pi over 27. If you need to, pause the video, go back, common denominators, et cetera. Okay, well, on the interval from 0 to 2 pi, I'm going to hit where the sign is 1 in more than one place. So if I have that theta is 4 pi over 27, it's going to hit that same value in another 2 pi over 3 length, I guess. So 2 pi over 3 is the same thing as 18 pi, I think, over 27. So from 4 pi over 27 and another 18 pi over 27, I'm going to hit 1. So I believe that's going to be 22 pi over 27. That's still less than 2 pi. Another 18 pi over 27 down the road, I'm going to hit positive 1 again. And that, I believe, is 40 pi over 27. That's still less than 2 pi. Why 2 pi? Because we're solving over the interval 0 to 2 pi. Okay, well, another 18 pi over 27 down the road, I'm going to hit the sign is 1. So that's going to be 58 pi over 27. Nope. Nope. This is greater than 2 pi. So my 3 answers are as such. Okay, let's go back and review some even odd properties. The sign of negative theta is the opposite of the sign of positive theta. It's odd. Odd. Take the opposite of the angle, you get the opposite of the value. Tangent, same deal. The tangent of negative theta is the opposite of the tangent of positive theta. And cosine is even. The cosine of negative theta is the same as the cosine of positive theta. We're going to use this to help us solve. Let's say we have 2 sine squared theta is equal to 3 times the quantity 1 minus the cosine of negative theta. I don't like the negative theta, but I know my properties. I know that the cosine of negative theta is the same as the cosine of positive theta. So this is 3, 1 minus the cosine of positive theta. Like magic, I can't, excuse me, like magic, the negative on the theta, where did it go? I used the properties. Okay, so now this is problematic. So previously, I think in the previous video, we talked about doing a substitution. I've got a sine squared. I can substitute for sine squared. I cannot do a substitution for regular old cosine. So I'm going to take out the sine squared, and I'm going to write it as 1 minus cosine squared. And I'm going to distribute. Sine squared, same as 1 minus cosine squared. So there are 2 variations. There's actually 4, but we'll get there in a minute. Okay, so I'm going to distribute. I'm going to set it equal to 0, and I'm going to factor. So 2 minus 2 cosine squared, 3 minus 3 cosine. 0 product property. think you can do the rest without me. So let's factor this. You can absolutely factor with trig functions. You can factor and solve quadratics. Zero product property. So the cosine of theta is 1/2. That's going to be pi over 3 and cosine 5 pi over 3. And the cosine of theta is 1, and I believe that's at 0. Why not 2 pi? Why not 2 pi? Because the initial directions that I gave you at the beginning of the video said that 0 was included and 2 pi was not. If they were both included, then you would say 0 and 2 pi. Okay, I want to look at a variation of the sine squared plus cosine squared is 1. So I showed you previously that you can very easily derive this identity. If I divide the entire equation by, let's just do sine squared. If I divide the whole thing by sine squared, that gives me 1 plus cotangent squared equals cosecant squared. You don't need to memorize it. I'm pretty confident you can figure out that cosine over sine is cotangent. And if I take this identity and instead of dividing by sine, I divide by cosine, that says divide by cosine squared, sorry. Sine squared over cosine squared, this is going to be tangent squared plus 1 is secant squared. Okay, and of course there's variations. Subtract cotangent squared from both sides, or subtract 1, et cetera, et cetera. There's lots of variations of these. But as long as you know sine squared plus cosine squared, you're good to go. Okay, well, we're going to do a problem that involves this. So let's say we have cosecant squared is equal to the cotangent plus 1. Okay, I can do a substitution for cosecant squared. I can do any substitution I want with the squared functions. I cannot substitute for cotangent, as is. So I can say that cosecant squared is 1 minus cotangent squared. And now all cotangents, good to go. So let's see, I'm going to get 0 equals. I always like to keep the a part of the quadratic positive. I don't like factoring with negatives. Plus cotangent. Subtract 1, you get 0. And I don't know why, but when it comes to factoring out just a plain old GCF, I get a lot of confusion. So take out a cotangent. Oops, that says CO. That's clearly a mistake. There should be no S. Cost, no cost. How about cotangent plus 1? That says cotangent, sorry. Oh, whiteout stinks. All right, so cotangent is 0. Cotangent is -1. So unfortunately, I just realized I made a mistake. Cosecant squared is 1 plus cotangent squared. So this should be cotangent squared minus cotangent. And this should be -1 and this should be +1. Sorry about that. I made a mistake. Cosecant squared is 1 plus. So you subtract cotangent, you get minus. And then this is cotangent. Okay, so cotangent is 0 where the cosine is 0, which is at 0 and pi. Wow. Sorry, guys. Cosine is 0 at pi over 2 and 3 pi over 2. And the cotangent is +1 in quadrants 1 and 3 with a 40 pi over 4 reference. So that's pi over 4 and 5 pi over 4. I'm just going to go through it one more time. I substituted in cosecant squared was 1 plus cotangent squared. And then I set it equal to 0 by subtracting cotangent theta. So that's what this says right here, minus cotangent theta. And then I factored out cotangent, and that leaves me with cotangent times the quantity cotangent -1. And then the cotangent is 0, or the cosine is 0, which is at pi over 2 and 3 pi over 2. Let's look at the calculator. Let's look at the calculator. I tend to be in radians when I graph. It doesn't really matter. But I'm going to stick with radians. Let's go ahead and get your calculator. And we are going to solve x squared equals x plus 3 cosine of 2x. Okay, well, all you gotta do is plug in. So I'm in radians. I would be in radians too, if I were you. So on your calculator, go ahead and plug in. X squared is one of your equations, and x plus 3 cosine 2x is the other equation. This graph is so cool. And when you graph it, so cool. So how to solve this? Just like you've been doing forever. Second, trace, intersect. And then get close, enter, second equation, enter. About -0.6. And y is approximately 0.38. It's an ordered pair, -0.616 and 0.38. I didn't tell you how to round. Just going to leave it as is. And then again, second trace, intersect, enter, enter, enter. We have 0.81 and 0.658. Oops, forgot the decimal point there. All right, so you already know on the calculator, but isn't this graph totally cool? Like watching it graph, I thought that's pretty awesome. So when you get these funky equations like such, that is literally a matter of definitely just plugging into your calculator. All right, you guys have a good one.